Well, just like there's such a thing as a partial derivative with respect to x or y or whatever variable, believe it or not, there are also higher order derivatives, that's second derivatives.
Turtle? I have a feeling we're not in Kansas anymore.
And even if you are in Kansas, such things exist. We could take the partial derivative of a function with respect to x and then differentiate that function again with respect to x, and you would have the second partial derivative of that function with respect to x. Similarly for y, and that's not too much of a challenge. I think you can understand that. Now this is weird. There's a partial derivative, second partial derivative with respect to x, and then y, or y and then x, and that would really make you think.
Turtle? I have a feeling we're not in Kansas anymore.
So yeah, such things exist. By the way, they could be notated with a double subscript x, y, or yx on the function f. So here's a question. Find all the second partial derivatives of the function of two variables f of xy equals x times the cosine of y plus y times e to the x. So the partial derivative of this function with respect to x, well, if we're differentiating with respect to x, then cosine of y is just a constant. So the derivative of x times a constant is just a constant. Plus, now don't forget, y is a constant, so when we take the derivative of e to the x, we still get e to the x times its constant multiplier, and that's the first derivative of this function with respect to x. What is it with respect to y? Well, if we take the derivative of this with respect to y, then the x is a constant. The derivative of cosine is negative sine, so we got the constant x times negative sine of y. And then differentiating y times e to the x, keeping in mind e to the x is considered a constant, and a constant times y, the derivative with respect to y is just a constant, so plus e to the x. Continuing onward, the second derivative of this function with respect to x, we go back and take the derivative of this function with respect to x. Well, keeping in mind the derivative of cosine of y, since cosine of y is considered a constant, is going to be 0. Plus y, the constant, times the derivative of e to the x, which is just e to the x. So y times e to the x is the second derivative with respect to x of this function. Now, we also have a second derivative with respect to y, so we want to take the derivative of this with respect to y, and that means x is a constant, so this part's a constant, and the derivative of sine, of course, you know to be cosine, so we get negative x times the cosine of y times the derivative of e to the x. Well, the derivative with respect to y of e to the x is 0, because e to the x is considered constant with respect to y. So here's these two second derivatives, but we've got more. What's the derivative with respect to x? Actually, the derivative with respect to y of the derivative with respect to x. So we find this one first, derivative with respect to x, and then we differentiate this with respect to y. So if we did that, the derivative of cosine of y with respect to y is negative sine of y, and the derivative of y times e to the x with respect to y, see, e to the x is a constant, so it's just e to the x. So, similarly, when you find fyx, you find fy first, which we already did, and then take the derivative of this with respect to x. Well, that means sine of y is a constant, so we get negative sine of y, because the derivative of x is 1, so we get negative sine of y, plus the derivative of e to the x with respect to x is again e to the x, and I want you to notice something here. These two partial derivatives, the derivative of fx with respect to y and the derivative of fy with respect to x, are the same. So the next theorem says that we can expect that under good conditions. That will be in the next video.